These first 20 questions were definitely a vast array of choices. First one was just a general solving for x, right? Move all the x's to one side, get x by itself. We get a 3 for an answer. Not too bad. Question number 2, we saw a question like this, I think yesterday with the overtime, or maybe the day before. 14 bucks an hour. She gets overtime. Our copy came out bad, but on the actual ACT, it comes out just fine. She worked and she earns 1.5 times. How much does she work if she works 48 hours? Well, there's 40 hours at 14 plus the overtime. There's 8 hours of overtime, and she's going to get 1.5 times for $14. Definitely use a calculator on that. Number 3 is writing an equation. If you glance at the answers, that kind of helps you see some stuff. It looks like there's lots of subtraction here. We're told that we had a tank of 200 gallons. So I kind of drew a tank with 200 gallons, and it's losing water at 4 gallons per minute. So I'm like, oh, that's got to be 200 minus 4t, where t stands for every minute. Any questions on 1, 2, or 3? Great. Okay, question number 4 is dealing with exponents. You got to remember that when you're multiplying here, you have to add the exponents. They've got a lot of really good distractors here where you're going to be multiplying them, so be careful. 5 we have not talked about yet. These geometric sequence occurs about once every 4 exams, and we've done 4 exams, so we're kind of thinking about it. It's on our formula sheet, the sequences, and what you have to do is figure out the pattern. Like, what are we doing here? Geometric means that we're always multiplying by something. That's what geometric is. If it was arithmetic, we'd be adding something every time. Well, geometric, I'm like, well, what are we multiplying by? It looks like we're multiplying by a negative number, and I know that the next answer here has to be positive. So I could safely eliminate those 2 right off the bat because those are negative. And I'm like, looks like we're times them by 2 here. So we must be multiplying by a negative 2, which would be 384. So number 6, that one is kind of just right out of science class, converting one unit to the other. Like, how many minutes would it take a car traveling 120 miles at a speed of 50 miles per hour? Well, 120 miles, we know that we're going 50 miles per hour. So I'm going to make sure the miles are diagonal, they'll cancel, and convert the hours into minutes, and we get 144 minutes. Some people just in their head, they think, 50 divides into 120 how many times, and then you times by 60. That's exactly what we're doing here. 7, people are painting, and they started with 6 gallons of paint. They used a half gallon and 1 3/4 gallons. So that's like, 6 minus 0.5 minus 1.75. Definitely use your calculator. It'll be really fast, and you can get the subtraction. You'll get 3.75. Number 8 is our Pythagorean theorem question. Now, I always draw a picture when we're given a geometric question. We're told the hypotenuse is 50 and one of the legs is 40. I'm like, oh, 50, 40. Yeah, that's a 3, 4, 5 triple. This side must be 30. Very quick with the triple. If you didn't know the triple, you'd have to do the Pythagorean theorem to solve it all out. That would take some time. The triple is really, really fast. Any questions on 4 through 8 at all? Okay, let's look at 9. 9, I think, is our second stinker in here. It's pretty dense. They're giving us lots of information, and they want to know how many spaces that are not reserved for handicap parking. So all the ones that are not reserved for handicap parking, how many of those are suitable for non-compact cars? Man, okay, well, first off, let's figure out how many spaces are not reserved for handicap parking. Well, we know that 8% are reserved. So that must mean that 92% of them are reserved for not handicap parking. So I'll do 0.92 times 450, and I get 414 are not handicapped. Now, it says of those parking spaces not reserved for handicap parking, that's what we're talking about here. Of the spaces not reserved, it says 18 are suitable for compact cars. So subtract 18, we get 396. That one's pretty rough. I'll admit it. That one, I had to think about it a bit just because there was a lot of reading in there. 10, I think we had in our math notes earlier with the person planting trees. The first one has one tree, the next one has two more. We're adding two every time. By the way, this is what an arithmetic sequence is. We're adding two each time. Just add them up on your calculator, you get 49. Question number 11, they tell us A is 3 and B is 5. So how much is this? I really want to use the calculator on this one, and I want to go right from the start here because I want to show like it's much faster to type that in. So I'm going to go and press alpha y equals and choose the top choice, get a fraction, 3 over 5 to the second power plus, and instead of, I know 8 over 2 is 4, but you know, maybe I forget and I want to type in the fraction again. 8 over 4, I press enter, 53 over, hold on a second. 8 over, oh, gee whiz. It's 8 over 2, isn't it? Okay. 103 over 25. And that's what our answer is here. Question number 12 is our second time we've seen this least common denominator. So if you wanted to add these up, what would be the number in the denominator? Well, I look at these denominators and I break them down, right? 21, 7 times, you know, I figure out their prime factorization here. And I got to make sure all those pink numbers are in my least common denominator. So I've got a 7 and a 3. And then I need to have a 3 again. Well, I've already got a 3. I'm good there. I need 2 2s. So 2 2s. And then this one has 3 2s. I got 2 already. I'll just need 1 more. Do the math here. I get 168 as the common denominator. 13, they give us the formula for the number of the sum of the angles in a polygon. And they tell us that the sum is 1440. How many sides does it have? One way is to go about solving it, but you know, a quicker way, you know, these are in order, right? So I'm going to guess 10. I 10 turns out to be the right answer, but I'm going to go ahead and try to, you know, what can I put in for n so I get 1440? So I could do 180 parenthesis. I'm saying 10 first. You know, 1440, we get it. Now, and if it wasn't correct, I could press the up arrow, copy it down, and change that 10 to be an 8, and so on. I think it's really fast using the calculator to evaluate it. Yes, we can all solve this equation pretty quickly, but some people, they need that calculator to help them out. Any questions on 9 through 13? Okay. 14 was the second stinker in the question. There is an algebraic way that you could solve this one. See, we're told that, you know, we know that this is 4 and this is 6, which means the area here is, by the way, the answer is F. The area here is 24. We got to figure out what could go here, right? These two measurements to make this area twice as big. So that means the area's got to be 48. Well, I mean, one side would be 6 plus x, right? And then the other side would be 4 plus x. And I want to find out when you multiply those, you get 48. That's going to get you really bogged down in some nitty gritty algebra of expanding and then refactoring. And trial and error is something that we don't do a lot of in our math classes, but it's the best way to go on this one. We're trying to get an area of 48. So I'm going to first off guess this length. I'm looking at my choices here, and I'm going to stick with the integers first. I'm going to try out a 4. Well, if this distance is 4, then the width is 10, right? Because it'd be 6 plus 4 would be 10. So our distance here is 10. And if this is 4, 4 plus 4 is 8. So we've got 8 and 10. And when I multiply those, I get 80. That's too big, right? We're trying to get 48. So I knew it couldn't be 4. I decided next to try out the other integer 2. So if that distance is 2, well, then this height is 8, and this length is 6, and 8 times 6 is 48. It's really pretty fast. So think about this using a table and trial and error. ACT really seems like they're really focusing a lot more on this trial and error business. It's a quick way to get the answer. I know in math class we would say, no way, you can't do that. You've got to do it this way because we wouldn't give you the answer choices. But this is the ACT, right? It's multiple choice. Any questions on 14 at all from anyone? Okay, let's look at 15. Anytime they give me points, I always really like to just plot them out on a grid to help me out. So I know it's 3 comma 8, which is here. And we're told what are the coordinates of A prime? And if I don't remember what that means, because geometry was so long ago, it means the image of A after it is reflected across the y-axis. Well, reflected, well, we know what that means, right? So this piece is going to go all the way over here. So the 8, the y value of 8 will still stay. So I could safely, boy, I could just eliminate right away and get the answer because letter C is the only one with an 8 for the y value. Okay, 16. Pretty heavy algebra. Here's your quadratic. They want to know the sum of the two solutions. So you got to factor this, right? Got to solve it. Got to add those numbers up and get -3. But you know what? Maybe you've had a hard time factoring, right? Well, what you can do is you could take this and graph it, right? Let me go to my calculator and just graph it. Oops. X squared plus 3x minus 54. I'm just going to go ahead and graph this equation because I notice these are all nice integers here, so we probably should be okay. So my graph's not big enough to see, but I can kind of see where it crosses, right? We have to know that solutions, that means when this equation works. In other words, when does this equation equal 0? Well, it equals 0 at this point here, which if I count these would be -9, which is what I got here. And this point over here, which if I count these is 6, which I got here. So it's okay to graph them if you don't remember how to factor. Nothing wrong with that. We're just trying to get good answers quickly. Did that make sense for people? Anyone want to talk about that more or? Okay. And I've got it on here so when you guys get the answers and such. 17, we're told the area of a certain square is 36. So I drew a square and put 36 inside because this helps me out. And the question says, what's the perimeter? Well, if this is 36, both these sides have to be 6, right? Because it's a square, all sides are equal. 6 times 6 is 36. Well, all the sides have to be 6. So we must have 24. 18, yeah, you could go through and multiply all these, but we should remember that when we're multiplying, numerators and denominators cancel out. Like this 4 would cancel with this 4, and this 5 would cancel with the 5, and 6 with 6, and 7 would cancel with 7, and we're left with 1 times 2. Now, I know I could cancel to 3 and 9, but let's say I miss it. 1 times 2 times 3 is 6. 8 times 9 times n is 72n. I don't see it, but if I reduce 6 over 72, I'll get 1 over 12. So it's 1 over 12n. There's such a variety on these first 20 of this test. This one here, 19, scientific notation. Scientific notation appears on about every other ACT. They want to find out what this is. Now, some people kind of really get hung up on like, there's a special button to press for the scientific notation and stuff. Don't worry about it. 3% is 0.03. I'm just going to type this in exactly the way I've got it written, 0.03, and then 5.13 times 10 to the 5th power. I'm not going to worry about the, I'm not going to worry about the EE key or what button I press. I'm just going to type it in the way it appears. And sure enough, I get the answer. Okay, so don't get hung up on that stuff. Last one is trigonometry. We got a triangle here, and I think we may have done this one in our trig practice. Which of the following expressions equal to it? We glance at the answers. Wow, there's a whole bunch of trig here. We'll think of SOHCAHTOA. And I just start going through them, right? Here's 35. Now, sine is opposite over hypotenuse. Opposite hypotenuse. That's not it. Let's try cosine, adjacent hypotenuse. Adjacent hypotenuse. That's not it. We'll try tangent. Opposite over adjacent. Ding, ding. That's it. Tangent of 35 equals x over 10. Multiply both sides by 10. We have our answer. All right, like I said, we're going to have plenty of time today to do lots and lots of ACT questions. So I think I would like for us first to do, let's do probability. So let's all have everyone go to question number 24, and I'm going to give you a minute to do this one. 24. Here we go. Here it is. You have 1 minute to come up with the answer. Okay, so this one should be letter K. We're told that they are mutually exclusive, and that means that each event doesn't interfere with the other. What's the probability that event A or B will happen? We need to remember that when we're doing this, we add them up. So 0.2 plus 0.6 is 0.8. Okay, so turn the page. Let's get to number 27. Now, 27 is a probability question, and 27 is part of this conglomerate of questions. So you have 1 minute to do number 27. Okay, this one I think would have been pretty quick. Question is like, what's the probability that the film has only one word in it if it occurred after 1965? This is kind of the math way to write it out. Probability of one word such that we're after 1965. I look, these are the dates after 1965. There's 2 films with one word, Topaz and Frenzy, out of a total of 4. So it's 2 over 4. Kind of weird they didn't reduce the fraction, right? We're always telling you reduce, reduce, reduce. Don't have to. 2 over 4. Okay, let's do another probability question. This one is number 49. So get into those tougher ones. Now, 49, I should tell you, it's at the top, right? But 49, okay, is still part of this other grouped questions on the left-hand side, okay? So question number 49. Again, I'm going to give you 1 minute to work on it. Okay, now we need to be careful on this one. I know it's a 20-sided die, right? But every side is not numbered the same, right? We're told it happens in equal amount of chances for each of these, but the question says um, we'll have 3 dots, right? So if I look at my table here, I'll say the number of pieces with 3 dots. There's 3 faces of that, so 3 sides. So the probability will be 3 out of the total of 20 sides. And when I divide that out, I get 0.15, which is letter C. Okay, right below it is our very last probability question from this test. Number 50. Go ahead and take 1 minute on this one. Okay, so this one here, right? It's kind of an interesting question. And ACT has really worded it nicely for us to not need a calculator, but it's okay. We have one thing that we have now. Their names are taken out of the box without replacing. So once a name is drawn out, it's not being put back in. So once you answer a question, you're not going to answer another question. She's already had you, or Mrs. Zoo's already had you answer the question. So we're trying to figure out the probability that Tom's card will not be drawn, right? We're not going to pick Tom at all. Well, for the first one, so again, we're doing 4 draws, right? 1, 2, 3, 4. The first one would be, the probability would be 23 out of 24, right? There's 23 names in there that are not Tom, because we're trying to find out the probability that Tom's card will not be drawn. So the first probability is 23 out of 24. Now we're not replacing it. So the next would be, there would be now not 24 cards, but 23 cards. And we're assuming Tom was not drawn. So there's 22 possibilities there. And again, we're not putting it back. So now there's 22 cards and 21, and then 21 and 20. Again, the nice thing here is that those cancel and we're left with 20 over 24, which this time they want you to reduce to get letter J. So this test had 4 probability questions. This one's not bad. It's in the 50s. It's not too bad. Okay, I'd like to kind of finish up with doing some area and perimeter questions. So we've already done 2 of them, 14 and 17. But if you could go to question 41, there's our first area and perimeter question. So take a minute and answer number 41. Okay, so this one was a little bit interesting, right? We had to find the ratio of the area of this trapezoid to this triangle here. And the thing is, there's no way to find the exact area of that triangle. But we should notice that if this is 40 and this is 60, there's a distance of 20 left over, which means this has to be 10, and so does this, right? And then I'm looking at this, I'm thinking, man, maybe we're going to do groupings of 10. Maybe I should see how many of these triangles I could divide this into. Well, each width will be 10, right? So I'm not a great artist, but I would do this because this is 40. And then I might just say, I know that all of these triangles are going to be exactly the same. I didn't draw it very well. In my notes, I did draw it much better, okay? Because they all have the same height, right? And they all have the same base of 10. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. And there's only one of this triangle. So the ratio is 10 to 1. Really, really pretty challenging there. Okay, right below there is another area and perimeter question. It's number 43. Now this one, I'm going to give you like a minute and 20 because I think this one might take a little bit. Okay, I'm going to show you how I did it, and I'm kind of curious how other people did it. So if you did it as a different method, please share it. First of all, the answer is letter E, okay? Now we're told that these have a radius of 3. So radius of 3, so I'm just going to kind of put all those 3's in because it only takes like 2 seconds. And then what I thought of, the way I did it was I said, okay, we're going to find the area of this square, right, which is 6 by 6, right, because this is 6 by 6. So that's going to be 36. And if I glance at the answers, I'm feeling pretty good. Like, hey, there's a 36 there. That's all right. Now I'm going to subtract all of these pieces. Now I noticed that on these pieces, right, each one of them is a fourth of a circle. If I put all 4 of those pieces together, I'm going to get a complete circle of radius 3. And the circle is pi r squared, so minus 9 pi. Did anyone do it differently at all? I'm really curious. Okay. Very good, very good. All right, let's do one more area and perimeter question, and it is number 48. So just turn the page once. It's back to this 20-sided die again, and it's this right down at the bottom here, number 48. I'm going to give you a minute and 30 seconds on this one because hopefully we've saved some time for these tougher ones. Go ahead and give it a go. The 45, 45, 90. So what that means is, let's say this side is 3, this side is 3. Well, then this side would be 3 times the square root of 2. A lot of times on the ACT, if they have one of these triangles on here, they like mixing up the angles. They're kind of lucky here to us that all these are root 3. Sometimes they'll throw in some root 2's in there to try to confuse you a bit. Okay. So we've done our probability. counting. Have we done all of the trig? Oh, I remember what I wanted to do. This quadratic. So if you could go to question number 35. Got to turn pages back a little bit. 35 here. And I think I kind of just want to work this one with you. It's a bit of a doozy here. Trying to figure out which of these would give us this. And you're like, what? There's not one number in this problem except for the second power there. Well, the best way I could think about this one, and if I glance at the answers here, I notice the first parentheses all have a K and an X or a K and an R. And this has, so it's really hard to kind of go through these. The best way I can think of on this one is to do a little bit of trial and error. Well, I think about, we could notice one thing here. We're multiplying, right? And we know when we multiply, the first terms get multiplied by each other, the last terms multiply each other, and then we have this outside and inside. It's this 4-letter F word called FOIL. Well, when we multiply those last two numbers, we should get plus mn, right? So if I look at letter E, negative n times negative m would be a positive mn. Okay, we can't get rid of that. We look at D, it's m times n, that's still a positive mn. But C, positive m times a negative n would not be positive, right? Same thing on B. When I take a negative m times a positive n, it's not going to be positive. So I could safely get rid of at least B and C based on that. I could also look at the first numbers that we're multiplying. We got to get this, right? So if I look at the first two numbers that's left, like here, kx times rx, that would be krx squared. Yeah, that's fine. If I multiply these two together, krx squared, yeah, that's fine. Kr times rx, this would give us kr squared x, which is not that, so we could safely get rid of this one. So that didn't take really too long to go through, maybe 30 seconds. Now we've got to do trial and error to figure this out. I'm going to guess letter D. I'm going to multiply those out. Kx plus m times rx plus n. Now I know some of you are really good at foiling. I'm going to give a technique here for multiplying in case you have trouble with this, right? Because that's why we're here trying to prep some stuff. You can always do this area model. So kx plus m, this first piece will be kx, the second part will be a positive m. And I always put a plus sign there because it says a plus sign. And then here, rx plus n. So I'll put a plus n here. And now I'm just going to multiply these. Multiply these two pieces, it'd be krx squared, which we have. Multiply these two pieces would be rxm. Multiply these two pieces would be nkx. Is that right? nkx. Which one am I doing? I'm doing kx plus f, kx plus m, and then rx plus, okay. And kx, and it's right here would be mn. Okay. So I'm going to write up all four of those black numbers there. We have krx squared, which is first in our answer. And then we have this rxm, and then an nkx, and then an mn. Now, if we look at our answers here, this piece here looks like the letter x has been factored out. Well, if I look at what I have here, krx squared, in this piece, we can factor an x out of all that. And then plus mn, and voila, we have it. Okay. Let's see here. 52. Okay. If you would go towards the end of the test, let's do a statistics question now. It is number 52. Okay. Number 52. Come on, you. Let's work with me here. All right. I'm going to give you the full minute and a half on this. Go ahead and get started. Okay, I kind of think of all the math questions on this ACT. This one, I think, for me, was the most fun because it was really, really different than anything we've seen. Now, they tell us Veronica she took 3 math exams, and we had to find the mean number of points, like the average, right? So I'm thinking, okay, she has 3 exams. And they're giving us the median, the range, and the maximum. Well, the maximum is 90, so that must be the biggest score, right? 90. We're also told that the median is 80, so the middle value is an 80. And then it tells the range is 11. Well, the range is how far apart the biggest score is from the smallest score. So the smallest score has to be 79, right? Because 79 plus 11 would be 90. I just found that really cool of being able to pick those up. And then to find the mean, you just add them up and divide by 3, and we wind up with letter H. Okay, Mr. Williams, are you there?
I am.
All right, well, I